Plant-based milk fortification, adding organic minerals and vitamins to organic soy or oat milk. A gradual examination of fortifying plant-based milk using organic methods. It is a delicate procedure to fortify organic milk derived from plants like soy or oat milk. The word organic introduces a crucial degree of complexity because it significantly limits the origin and processing of the fortifying agents when compared to traditional fortification. While adhering to the rigorous organic certification requirements, the objective is to improve the nutritional profile, usually by replicating the important elements in cow milk such as calcium, vitamin D, and vitamin B12. Step 1. Determine the regulatory and dietary objectives. It is essential to first establish exactly what the fortification is intended to accomplish and under what restrictions. Target nutrients. Typically, the focus is on calcium, vitamin D, and vitamin B12, since these are frequently found to be lacking or less bioavailable in unfortified plant milks when compared to iodine and riboflavin B2 can also be included. Organic certification restriction. The game is changed by this. In most cases, organic standards forbid the incorporation of man-made vitamins and minerals. The fortifying ingredients must come from organic sources, or if from mineral origins, they must be allowed by the particular organic regulation, e.g. USDA organic, EU organic. This severely restricts the kinds of fortification components that may be used, which are usually inorganic mineral salts like calcium carbonate or manufactured vitamins. It is difficult to locate a cost-effective, organically acceptable source for all the necessary nutrients. Target levels. Nutritional targets are frequently established as a percentage of the recommended dietary allowance, RDA, per serving, with the goal of replicating the naturally occurring concentrations of cow's milk or meeting the regulatory standards for substitutes. Step 2. Obtaining organic fortification ingredients that comply with regulations. After establishing the dietary objectives, the emphasis switches to selecting components that are both organically compliant bioavailable. Organic calcium source. It may be challenging to locate calcium that is certified organic. Calcium carbonate is a typical fortifier that is mined rather than categorized as organic. Depending on the particular organic certifier's regulations regarding processing and natural origin, seaweed-derived calcium such as lithothamnium SP may be allowed in organic standards as a mineral supplement. Before being used, these sources must be thoroughly checked for organic status and purity. Organic vitamin D source. Plant milks usually contain vitamin D in the form of vitamin D2, ergocalciferol. UV-treated organic mushrooms or yeast that naturally create significant amounts of vitamin D2 when exposed to ultraviolet light are frequently used as a compliant organic source. The fortifier is the powder or extract that results. Organic vitamin text B12. Source, vitamin text B, P12. Cobalamin is only found in bacteria, not in plants. Finding a real organic text B12 is likely the most difficult step. The most popular approach is to dry or extract the organic certified substrate, such organic molasses, on which the text B and A12 producing bacteria are cultivated in order to produce an organic compliant powder. Other organic certifiers, however, may permit the use of some excellent non-synthetic text B HAN12 products under certain exceptions, but this is very rare. Additional nutrients, e.g. iodine, text B, HAN2PAD. It could be possible to obtain iodine from organic seaweed extracts. Riboflavin, text B2, is sometimes produced through an organic fermentation process similar to text B12, but it is often hard to find in an organic compliant form. Step 3, determining the stability and bioavailability of the components. The nutrient's form is crucial in determining its bioavailability, or how well the human body can absorb it, and its stability, which refers to how long it stays active in the milk. Bioavailability issue. Different organic approved mineral salts of calcium, such tricalcium phosphate or some citrate forms, have different absorption rates. To make sure the selected organic source is absorbed efficiently, it needs to be tested. In a similar vein, vitamin D and B12 need to be biologically active in their current form. The milk's stability matrix, the fortifiers must stay stable during the shelf life. When exposed to light, heat, during pasteurization, UHT, or oxygen, vitamins, particularly D and B12, can break down. The product's packaging, such as opaque cartons, and processing procedures should be designed to maintain nutritional integrity. Avoiding sedimentation, calcium sources, which are mineral salts, tend to be less soluble in milk. As a result, the mineral powder precipitates and forms sediment at the bottom. Manufacturers may need to utilize organic stabilizers, such as organic gellan gum or organic carrageenan, if allowed and desirable, to maintain the fortificant evenly dispersed throughout the liquid, and should also take care to choose a form of the mineral that is highly dispersible. Step 4, incorporating fortificants into the organic milk base. The next stage is the physical inclusion of the chosen components into the organic oat or soy milk formula. Making the organic milk base. The soy or oat milk must first be made in accordance with organic standards, utilizing organic soybeans or oats, organic water, and organic processing aids, such organic enzymes for oat milk. Premix creation. The organic vitamins and minerals in powder form are usually combined with a tiny bit of the liquid base and an organic stabilizer dispersing agent to form a premix slurry. When added to the bulk, this guarantees uniform distribution and prevents clumping, homogenization, and controlled addition. The premix is added to the massive batch of soy or oat milk. This addition is often performed after the main extraction DOS filtration step, but typically prior to homogenization. To ensure the fortificants are properly and permanently dispersed and suspended, minimizing the chance of sedimentation, the mixture is then homogenized using a high-pressure procedure that breaks down fat and suspended particles. Process modifications. During heat treatments, such as pasteurization or UHT, the milk's protein stability and pH can be impacted by the inclusion of specific minerals. This may have unfavorable consequences, such as flavor alterations or curdling. Changes in the formulation, such as the use of organic pH buffers, may be necessary to preserve the integrity of the product. Step 5, organic certification, testing, and quality control. The last steps include thorough testing and making sure that all paperwork is in place in order to preserve organic integrity. Analytical testing. The finished product must undergo analytical testing after fortification to ensure that the target nutrient levels are reached and that the concentrations are consistent and accurate across batches. This is essential for adhering to labeling and regulatory regulations. Additionally, tests are performed to confirm the stability of the nutrients over time and to check for the presence of impurities. Stability and shelf life testing. Over the entire expected shelf life, samples are monitored to see whether they exhibit physical stability, no excessive sedimentation, separation, or off-flavor development, or nutritional stability, no significant degradation of the fortificants. Labeling and documentation. The packaging must clearly list every component, including the organic fortificants. Every step of the process, from the source to the handling of the organic fortificants, must be thoroughly documented. The organic certifier's audit, which is necessary for legally labeling the finished product as organic fortified soy oat milk, depends on this documentation. The organic assertion must cover the method used for integrating the new components as well as the new components themselves. An organic plant-based milk manufacturer can overcome the difficulties of locating, integrating, and verifying organic compliant fortification agents by following these 5 specific measures, which will enable them to ultimately create a nutritionally superior product that satisfies the rigorous standards for organic certification. Would you be interested in learning more about the unique difficulties in obtaining one of these organic fortificants, like organic vitamin B12? If you like, please let me know in comments.